Next, we comprehensively consider the one port containing RLC and dependent sources. In this case, we might as well assume that the initial phase angle of ut is 0 and it lags ut angle phi. It's noted that phi can be greater than 0 or less than 0 or equal to 0. We write the expression of the instantaneous power. We also need to use the trigonometric equivalent transforms, that is, so we can get Next, we draw the waveform of the instantaneous power of the general one port. We assume that the initial phase angle of the voltage is 0 and the current lags voltage angle phi. Here is the inductive load in the example. In this case, the waveform of the product of these two is like this. Look, the power is negative when the voltage is positive and the current is negative. The power is positive when both are positive. And the power is negative when one is positive and another one is negative. And the power is also positive when the both are negative. Next, we remove the waveform of the voltage and the current. We draw these two parts respectively. That is a constant DC part and a reversible alternating part. We can find that for a general one-port network, its absorbed instantaneous power have positive and negative parts. That is to say, it sometimes absorbs power and sometimes supplies power. The waveform of the instantaneous power, which change over time, can be divided into a constant part and a reversible part changing over time. We have presented the expression of absorbed instantaneous power of general one-port network. We call it the first expression. Based on this, we can conduct further derivation by using trigonometric equivalent transform. That is, so the above item can be written as we can merge the part of ui cosine phi and we get the second expression about the instantaneous power. We draw the waveform of the second expression that is like this. Its absorbed instantaneous power, you see, this part is the part of no less than 0, and this part is the reversible part that changes between greater than and less than 0. That is to say, this is the first part of the irreversible, and this is the second part of the reversible. In the following next few lectures, we will discuss in detail the first and second one respectively. When you study the corresponding knowledge, you can review the related contents in this lecture. Well, that's the end of this lecture.